So continuing with our parabolas, we are going to do a process today called completing the square. And this is something that you maybe took a look at in geometry and probably need a good refresher on. So we'll be practicing this, but being able to complete the square will allow us to look at a parabola and figure out its shifting or its translations that have taken place based on the function itself. So here's a couple of rules that we're going to go through for when we are completing the square. First thing that we want to do is make sure all terms containing an x are going to be on one side of the equation. We're going to move all of the constants to the right. Everything is going to go maybe to the right-hand side. Okay. We're going to get ready to create a perfect square on the left in order to balance the equation. We're going to take half of the x term's coefficient and square it. And then we're going to add this value to both sides. And then we're going to write the perfect square. So I know that sounds like this makes no sense. Don't worry, we're going to try this. We're going to practice this. Those are the basic rules. So those are there in case when we're doing this, you need to kind of take a look back and see what's going on. Okay, so for this first exercise, it says the function y equals x is shown, is graphed on the right-hand side. And we're going to consider the quadratic equation, x squared minus 8x plus 18. So we're going to use that method of completing the square to transform that function so it looks like this. All right, so what do we do? Well, let's take this whole equation. And the first thing it says is we're going to move your constant. Okay, so we're going to move your constant being 18. I'm going to move it over here. Now, some people do this, some people don't. I like to do this. I think to me it looks a little bit easier to see what's going on with our completing the square process. Okay, so then it said we want to take our middle term and the coefficient of our middle term, which is a -8. And I'll do this over here. So to that -8, we want to take half of that. So if I divide that by 2, we get a -4. And then it says we want to square that -4. So if we square that, now we get a positive 16. And we want to add that to both sides. So keep in mind, if I add something to one side, I have to add it to the other to balance out the equation. All right, so I'm just not adding in random numbers. If I'm adding it to one side, I have to add it to the other, just to keep it equal, to keep it an equation. Okay, so now we're going to simplify here. So I have y minus 2 is equal to x squared minus 8x plus 16. Okay, so now we have to make, it says our perfect square factor. Well, our perfect square factor, that's coming from this term right here. Whatever half of that middle term is, that's always going to be the number that will make that factor that we're talking about. Okay, so let me move this work over to here. Okay, I'll call this like our little aside. All right, and so I'm going to make this factor. Okay. Factor is whatever half of the middle term was. Square it. And then I'm going to add the 2 back over, so now it's in the form that they're looking for. So I have x minus 4 squared plus 2. Let's just take a look back at this step here. It says x minus 4 squared. So just so you know where that's coming from, that would be x minus 4 squared. Okay. If we were to do FOIL to just check this out and make sure that this is actually this term here, I'll do this work down here. So first terms would get you x squared. Your outside terms would get you -4x. Inside terms, -4x. And then your last terms is a positive 16. So when we simplify, watch what happens. We're going to get x squared minus 8x plus 16. And that's what we had from our equation above. So that rule, that quick little step, that half of whatever your middle term is always makes this factor, that always works. That just kind of makes your factoring a little bit easier when we're going through this process. Okay, so now we have that equation. We've completed the square. And it says we're going to describe how the graph of y equals x squared would be shifted to produce the graph that we would have been given. Okay, so if we take a look at this, and I'm thinking, let's write this down here maybe so we can see this. of our transformations, going back to Algebra 1 a little bit, this 2 at the end, that's going to tell us we're moving it up 2 units. And this 4 inside the parentheses, that's telling us we're going right 4 units. So if I could take that back up to this graph, we're going to sketch the graph of this parabola by just using the vertex form. So this form right here is its vertex form. And we're going to use those transformations that we found. Okay. So all of my points have to go to the right 4 units, 1, 2, 3, 4, and up 2. So there's that coordinate. I'm going to take this and go 1, 2, 3, 4, up 2. Take this point, 1, 2, 3, 4, up 2. Same thing, all the way points, 1, 2, 3, 4, up 2. Same thing here, 1, 2, 3, 4, up 2. So this, connecting this out as best as we can, that's going to be your transformed parabola. It wants to know the coordinates of the turning point. So right here, that's your turning point. And we can say the coordinates here are going to be 1, 2, 3, 4, up 2. That should sound familiar to what we just did. So the coordinates are going to be positive 4, positive 2. That is your turning point. Okay. Moving on to our next question. So we're going to take a look at all 3 of these equations, and it says in the window shown below, and we're going to sketch these onto this graph that we have here, and we're going to use our calculator to help us get there. So using the calculator, change the windows, graph this all, we have these graphs sitting right here, and I can see our original graph, that x squared graph, that's the blue graph. I can see the 3x squared, looks like it's kind of taller, thinner, stretching up. That's our red graph. And then the 1/2 x squared looks like it's almost like wider and shorter and closer to the x-axis. And I'm looking at this saying each of these have their turning point at that location, 0, 0. Notice that if I were to compare that to the first problem that we did, there's no parentheses, there's no nothing to go with the x, telling us no shifting of our original parabola left or right. So that would keep your turning point for those parabolas right at 0, 0. Okay. So the algorithm of completing the square works best when a is equal to 1 and b is even. It works for every case. It's just, those are the nice easy ones. We're going to take a look at a couple of harder ones. And again, this may be the first time that you're looking at completing the square, completely understand. Don't worry, we are going to have plenty of time to practice this and master this in class. Okay, so we're going to take a look at this and notice what we're talking about here. So here's that a term that's not 1. Now it's a little bit more difficult. Okay, we're going to kind of follow the same steps that we did before with taking your constant and moving it to the other side of the equation. So I'm going to add that 2 over. So now we have this. If we think back to some of our units previous to this, I can find a greatest common factor. Now, they both have x, but I want to leave the x alone. When I'm factoring something out, I'm only looking at the constants, the coefficients, the 3 and the 12. So common with 3 and 12, I can factor out a 3. That's going to leave me with x squared plus 4x. And now the reason that we're doing that is because I want to get that a term to be back to 1. Because like we set up here, it's much easier when a is 1. Okay, so from here we follow that same step. We're going to find our middle term, and our middle term is 4. And we're going to take half of 4. Okay, so I'm going to take 4 divided by 2. That's going to give me 2. And then we take that number and we square that and add that to both sides. Okay. Sometimes I even like to do a little box because when I'm doing this, I'm thinking I need to add something equal to each side to balance it out. So what do I put in the box? I put what we just found, which is a positive 4. So over here, I'm just going to write that. That's going to be a positive 4. And now we're going to simplify. Okay, so 2 plus 4, we have a positive 6 over here. And now remember what we said. We're going to make this factor. The way to make the factor is always whatever half of the middle term was. And back here we found that half to be 2. So that means I have x plus 2 squared. And there's my factor. And now if I'm trying to get this to be our equation so that y, ooh, I made a mistake. Let's go back. Hold on 1 second here. This is what happens when you move too fast. Because this is our harder case to take a look at, notice what we actually added to this side of the equation. What we added to this side of the equation is a 12. Because not only did I put a 4 in this spot, but I have a 3 times 4. So really on this side of the equation, I'm adding 12. You got to keep that in mind. I made that mistake. I apologize. So actually back over here, to balance out the equation, we have to add 12. Okay? So now if I go back here, let's change this just to make this correct. 2 plus 12, that gets us 14 on this side. Okay, so that's what's making this problem a little bit more challenging. Not only do you have the 3 that you have to factor out, but then when you make this number over here, when you take half that term, you really have to ask yourself, what did I add to the whole right side of this equation? You added a whole entire 12. So I have to add 12 to the left side. I apologize for that. So let's go back and let's actually take a look at the factor now that we have to deal with here. Okay, so the factor is actually still going to be the same thing, because when I'm looking at what we did, like we said earlier, I took half of this term here. That's still going to be 2. Keep in mind that 3 is still on the outside. Okay, so the factoring part doesn't change. It's just what I add to this side over here. That's the part that we got to be careful with. Okay, continuing on. I'm going to subtract the 14 over. And so now we have our parabola in the form 3 times x plus 2 squared minus 14. Okay, so what that tells us, if we think back to our first problems, we can find your turning point. Your turning point is coming from this information here. Your turning point, and remember the form that they gave us, we have to change the sign here. So if that's x plus 2, really our turning point has a coordinate of -2. And then over here, same idea. All right, we're going to take our sign, we're going to change that sign, we get a 14. Okay, let's try this again. Same idea, we're going to be careful with that coefficient out in front. Step number 1, we want to move our constant to the front. So I'm going to subtract that over. So I have 2x squared plus 6x that's left. And if I'm looking at these two terms again, the coefficients I have are 2 and 6. I can factor out a 2. So we got to keep that 2 in mind when we are making our factors. Okay, so again, thinking to myself, I have to add something to this side. Don't forget we have to multiply it. Then I have to add that same thing in over here. Okay, so we find our middle term, and here's where it gets a little difficult. We find our middle term. Our middle term is 3. We take half of 3. Well, that doesn't do anything really nice. You could put it as a decimal, but you don't have to. So 3 divided by 2 is 3 divided by 2. And then we need to square 3 divided by 2. And when you square a fraction, you square the top and you square the bottom. So what that's telling us is that we are adding over here into this term. I would be adding 9/4. But keep in mind, I have to multiply that by 2 to determine what's going in on this side over here. So even if I did that work on the side, 9/4 times 2, remember when you have fractions, you multiply tops with tops, bottoms with bottoms. That would get us 18/4. But if we reduce that down, that really is going to reduce down to 9/2. So on this side, in this box, I'm adding 9/2. And you can use your calculator for the fractions. There's nothing wrong with that. Okay, so combining this, simplifying this up, I have y plus 7/2. Use your calculator if you need to. Okay, and then on, I don't know why that's a 2, but that should be a 1. When I add -1 and 9/2, I should have 7/2 here. Over here, when we are finding our factor, so remember what we said, the factor would always be whatever half of our middle term was. Half of our middle term was 3/2, and we square it. Okay, so now to get our equation, so that y is by itself, I have to subtract over the 7/2. And so now here's our final equation. So to get our turning point, we want to think to ourselves, we're going to take this one and change the sign. So now that's got to be negative. And over here, we have a negative 7/2 for our turning point. And again, if this is confusing stuff, don't worry. We're going to practice this in class. Okay, so a whole bunch of manipulation on our original term. We can see that we get this really kind of ugly formula. But if we put it into place, all right, if we use that formula based on what the x-coordinate of the turning point is from this formula, we said our last 2 times we have done this, take this coordinate and we're going to change that sign. So I can tell you the turning point of any parabola is always going to be a negative, since it looks like positive in the formula, a negative b over 2a. Okay, so it says we're going to use that formula to find the turning point for this parabola. Okay, so let's keep in mind here is our ax squared plus bx plus c. That's the equation that we have. If I'm trying to find the turning point, well, if I start by finding our x-coordinate, so our x-coordinate is going to be a negative 10 over 2 times a. So I have a negative 10 divided by 2, so that's going to give me a negative 5. So my x-coordinate for the turning point is going to be negative 5. But how do we find the y-coordinate for the turning point? Take this, plug it right back into that equation. Okay, so we have y is equal to, just watch your signs, negative 5 squared plus 10 times negative 5 minus 2. Okay. And if we simplify this, we're going to have 25 here. 10 times negative 5 is a negative 50 minus 2. So when we combine that all, y is going to be a negative 27. So let's put this all together. We get a negative 5, a negative 27. That would be the coordinate for your turning point. Okay. And we're going to verify our answer from part A by placing this into vertex form. So in other words, let's complete the square. Let's see what happens. So step number 1, we're going to pull the constant over. And I notice I don't have a coefficient of anything other than 1 here, so we're good. We can just do our regular completing the square process. So I find my middle term. My middle term is 10. I'm going to take half of the middle term, which is 5, and then we're going to square that 5, which is 25, and we're going to add that to both sides. Okay, so I know I have a 25 I'm going to add on over here, and a 25 I'm going to add on over here. I don't have to multiply it by anything because the term here is 1. Okay, so I have y plus 27 is equal to, now we're going to make our factor. I have x and our half of our middle term is 5, so half of our middle term squared. Now if we get y by itself, we have x plus 5 squared minus 27. Okay, so that's our vertex form. So now if we were to take a look at this, we could see, like we did before, we said we'd switch the sign, keep the sign for our vertex here, for our turning point. So our vertex would be the coordinate negative 5, negative 27. Switch the sign, keep the sign. Here's our vertex, and notice what we found back up here. Okay, and we could check that. We could check our answers on a table on our calculator using the original equation and this equation, and we would see that they are exactly the same. And I will let you do that on your own. Plug them into your calculator and make sure that they are exactly the same, which they are. Okay, so we're going to find our turning points without doing the whole completing the square process, but by using that formula negative b over 2a. Okay, so again, I have, here's a, here's b, here's c. Make sure you understand b is negative 12. So our x-coordinate, I have a negative b, negative 12, over 2 times 2. Okay, so I have a negative times a negative, that would give me a positive 12 over 4, so my x-coordinate here is 3. Now, in order to find your y-coordinate, again, we have to plug that back in, so that's like saying the f of 3, and we're going to plug that in. Now, this, again, you could use your calculator and just let your calculator do the work. You could plug that into the table. You could type this whole string of information right into your calculator, and when you simplify that down, the f of 3 turns out to be negative 11. If we go way back to the beginning of the year, we said this would make a coordinate. The coordinate would be 3, negative 11, which should also make sense because I found x to be 3 and y to be negative 11. Okay. Over here, same idea when we're doing this. So I have x equaling a negative b over 2 times a. Now we got to be careful. We have a fraction and a negative. So let's just watch our signs here. So we have a negative 5 over 2 times a negative 1/4 is a negative 1/2. Okay, so negative 5 divided by a negative 1/2, and again, use your calculator if you're not sure, gets you 10. Okay, we want to try and find the y-coordinate that goes with that. So I'm going to take that 10 and plug that right back in. So I have a negative 1/4 times 10 squared plus 5 times 10 minus 20. Okay, again, plug that whole thing right into your calculator. Let your calculator do the work. Just make sure that you're plugging it in correctly, and you get 5. So now we put that together for your turning point, and we get the coordinate 10, 5. Okay, so I know this was challenging. We're going to go through this in class. Please make sure you come in with questions. We will practice this. We're going to get this completing the square down. Okay, hope you guys have a great day.